Hello, in this video we will talk about the transpose of the matrix. So the transpose of the matrix is obtained by swapping the rows and the columns of A. Okay, so here we have the formula. If you have a matrix A and you take its transpose, then its ith row and jth column will be swapped and you will write AJI. So in the original matrix it was AIJ. So after taking the transpose you will write AJI. Okay. Now there are some properties. So the first property is if you take the transpose of the transpose you will get the original matrix A. So the second property is if you add two matrices A and B and then take the transpose, you will get A transpose plus B transpose. And the third property is if you multiply two matrices inside and then you take the transpose, then you will get B transpose first and then A transpose. You know, in the when we take the product, then the order always matters. So if A and B are multiplying in this order, if A is first and B is second, and then you take the transpose, then it is equivalent to multiplication of B transpose and then A transpose. Okay, so you can't write this way, A transpose times B transpose. This is wrong, okay? So what is the correct way of writing is B transpose A transpose. So now we have some special kind of matrices. So the first matrix is symmetric matrix. I've already told you. It is the matrix in which A transpose equals A. Here is the example. If A is this kind of matrix, then we can find the transpose of A by converting this row into column first. You can see here is the column 0, 2, 5 and then this row into the next column. But you can see that this matrix and this matrix are same. Even after taking the transpose, there is no change. So that means the transpose and the original matrix are same. Hence, we can say that the matrix is symmetric. So the next property is, the next kind of matrix is the skew symmetric matrix. So the skew symmetric matrix is a matrix. If you take the transpose, you will get the negative of the matrix. Okay, previously we got the plus A and this times minus A. Here is an example. If you have a matrix, A is equal to this type of matrix, and then if you take the transpose, so first you will convert this row into column, okay, and then you will convert this row into column. Okay, so now you can check that this matrix and this matrix are different. But if you take minus common from this matrix, then what will you get? You will get 0 minus 1 inside and 1 0 inside. Okay, so then you can check that after bringing minus common, the inside matrix is exactly A. You can check now both are same. So that means A transpose is equal to negative times A. Okay, we can write A transpose is equal to negative times A. That means A is skew symmetric. Okay. Okay, now we have some practice problems. So I will solve the second problem from the practice problems. So in this problem, we have to verify that AB whole transpose is equal to B transpose times A transpose. for these matrices. So the matrices are given, so I have to verify this property. So in order to verify a property, we have to consider the left hand side as well as the right hand side. So we have to calculate both. And so first of all, we will calculate the left hand side. In the left hand side, we have A, B whole transpose. So first of all, I will put the value of A and then the value of B, and then I will take the transpose. Okay. So now, first of all, I will multiply inside. So if I multiply inside, I have to multiply this row with this column, which is here. So then this row and the second column, which is here. Now the next row and the first column, which is here. So the next row and the last column is here. And then I have to take the transpose. So I have written the transpose. Now just simplify. After simplification, inside I got this. Since I have the transpose also, so I will write the transpose. So the transpose means I have to convert this row into column, and then I have to convert this row into column. So this is done. So I have computed the left hand side. Now I will compute the right hand side of the matrix of the problem. So the right hand side is B transpose A transpose. Okay, so first of all, I will put the value of B, which is this matrix, and then I will write the transpose. Okay, then I will put the value of A, which is this, then I will take the transpose, which is this. Okay, first of all, I will apply this transpose on this matrix, and then this transpose on this matrix. So if I apply the transpose on the first matrix, so this row will become into column, and this row will be converted into the second column. And similarly, I will apply the transpose on the second matrix. So I will convert this row into the column and convert this row into the second column. And then I will multiply these two matrices. So first of all, I will multiply the first row with the first column. So it is 3 times 1 plus 1 times minus 1. And then again the first row with the second column, which is 3 times 0 plus 1 times 2. Okay, so then I will pick the second row and I will go to the second row and the first column, which is 1 times 1 plus 0 times minus 1. Again the second row but the second column, which is 1 times 0 plus 0 times 2. If I do these calculations, it is 3 minus 1, which is 2. Here I have 0 plus 2. Here I have 1. Here I have 0. Now you can check that this is the right hand side and this is the left hand side. 2, 2, 1, 0. You can check both are same. There is no difference. So I will write, since left hand side is equal to the right hand side, therefore AB whole transpose is equal to B transpose and A transpose. Now we have the third problem. It says find x and y such that we have this matrix equation. Okay, so let's solve this problem. Since it is given that this matrix equation, so we have to find x and y. So if you multiply this matrix with this matrix, that means you have to multiply this row with this column. That means 1 times x plus 2 times y. And then you have to multiply this row with this column. That means 0 times x plus 1 times y. Okay, which is equal to 5 times 3. So this is the product of first two matrices and the last matrix is the same. So equivalently, I can write x plus 2y here and here only y. Okay, so equals to 5 comma 3. So this is a new matrix equation. So if you compare the last term, then you can get y is equal to 3. And if you compare the first term, that means x plus 2y is equal to 5. X plus 2y equals 5. But y is equal to 3, you can put instead of y 3. You can plug y is equal to 3 here. Okay. So x plus 6 is equal to 5. That means x is 5 minus 6, which means x is equal to minus 1. This is the value of y and this is the value of x. So next we have power matrix. So for a square matrix A and a natural number n, we can always take the power n of A. So a to the power n is equal to a times a up to so on. This is n times a, right? So n times a is the power n of a. Okay, so in this power, we consider that a to the power 0 is always identity matrix. Okay, so just like the numbers, when you take any when you take power 0 of any number, you always get 1. So similarly, in case of matrices, you have any matrix and you take the power 0, you will get always identity matrix. So now we have some properties of the power of matrices. If you have a to the power m times a to the power n, then you can write a to the power m plus n. So secondly, if you have a to the power m to the power n, you can write a to the power m times n. So look at an example. If you have a matrix A and you want to find the square and the cube of the same matrix, then you can do. Since for the square you have to write a square equals a times a 2 times, because the power is 2, so you will write a 2 times. So you will write a, this is a and again a. Okay, so you will write 2 times a. So if you multiply these values, first of all I will multiply these two. That means 1 times 1 plus 0 times minus 1, and then you will multiply this with this, which is 1 times 0 plus 0 times 2, and then you will go to the next row and the first column, which is 1 minus 1 times 1 plus 2 times minus 1, and then you will go to the next column and the second row, which is minus 1 times 0 plus 2 times 2. Okay, if you calculate all of these values, you will get this matrix. Okay, now if you want to find a cube instead of a square, then you can write a cube is 3 times a. But we have already found what is a 2 times. Okay, we will put the value a 2 times and a. Okay, so this is the value of a and 2 times a is here. You can check, I have already found a 2 times, which is a square. Okay, so a square is already found. Now you can compute these values by multiplying these two matrices. So first of all, I will multiply this with this, which is 1 times 1 plus 0 times minus 3. Then I'll multiply this with this, which is 1 times 0 plus 0 times 4. Then I will go to the next row, which is minus 1 and times this matrix, 1 times 1 plus 2 times minus 3. and then I will multiply the last row with the last column, which is minus 1 times 0 plus 2 times 4. So if I calculate these values, I will get this matrix. Okay. Now there is an exercise for you. Just like I have calculated a square and a cube, you have to calculate a to the power 4. I am giving you the hint. You will write a to the power 4, a times a times a times a. Either you do this a cube and this a, put the value of a here, put the value of a cube here and multiply them. Okay. Or you can do this way. This is a square, this is a square. Put the value of a square here, put the value of a square here. You will get again two matrices and you will multiply. Whatever you want, it's up to you. Now we have an identity matrix. So identity matrix is an n by n matrix whose all diagonal entries are 1 and the non-diagonal entries or off-diagonal entries are 0. Okay, so if I have to write the n by n identity matrix, then I have to write the dimension n by n. So I will write 1, 0, 0 up to so on 0. Again 0, 1, 0 up to so on 0. And 0, 0, 1 up to so on 0. Similarly 0, 0, 0 up to so on 1. You can check that the diagonal here is containing only 1 and all the other than the main diagonal entries are 0. You can check. So this is an identity matrix of order n by n. Similarly, you can write the identity matrix of order 2 by 2 in this way. I2 is 1, 0, 0, 1. You can check this is the main diagonal and the other then the main diagonal entries are 0. Similarly, if you want I3, you can even write 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, the important thing is that you have to write all elements 1 in the main diagonal. So now we have a key property for the identity matrix. If you have any n by n matrix and you multiply this by the identity matrix of n order from the left side or from the right side, you will get the same matrix A. Okay, this is the key property for the identity matrix. So next we have zero matrix. You know what is the zero matrix? It is a matrix whose all entries are 0. Okay, so it has a key. So the key property of the zero matrix is that for any matrix A, if you add the zero matrix from the right side or from the left side, you will get the same matrix A. So next we have a diagonal matrix. So the diagonal matrix is a matrix which is also a square matrix, means n by n matrix, okay, whose at least one diagonal entry is not 0. I mean, in the main diagonal there is at least one entry which is not 0 and all the non-diagonal entries are 0. Okay, you can write the diagonal matrix D in this way. You can check here the main diagonal entries are other than 0. Okay, some of them can be 0 but not all 0, and all the non-diagonal entries are always 0, here also and down also. Okay, here I can write not all the main diagonal entries are 0. So I will write at least one of the diagonal entries is not 0. So the diagonal matrices have very nice key property. So the key property is, if you have a diagonal matrix, then it's any power k. So the any power k of D can be obtained but in this way. For example, if this is D, then any power will be obtained by taking the powers of the only diagonal entries. If you only take the same power of the main diagonal entries, that means you have no need to multiply the matrix with itself k times. Usually I told you, if you have a matrix A and you want to take its power k, you will write A times A times A times A k times. You have to multiply the matrix k times, as we did previously. I have given you the exercises also. But if the matrix is diagonal, you have no need to do this all work, because this work is huge work. But if the matrices are diagonal, no need to do all of these works. Only take the powers of the main diagonal entries, you will get the answer. For example, I have the diagonal matrix 1 0 0 0 3 0 0 0 5, and I need to find a to the 4. Okay, since A is the diagonal matrix, and then you can write a to the power 4 is equal to the power 4 of the diagonal entries and all other zeros. Okay, now you can easily calculate these values. 1 to the power 4 is 1 and these are 0. 3 to the power 4 is 81 and the rest are 0, and 5 to the power 4 is 625, and this is the answer.